In this video, we're going to have a look at calculating area and volume of similar shapes using their scale factors. So to calculate the volume of an enlarged surface area, you take the original surface area and times it by the scale factor squared. For the volume of an enlarged area, you take the original volume of the smaller similar shape and times it by the scale factor cubed. So let's have a look at an example. In the question, we have an area that is 712 meters squared, and this area is represented on a scale drawing by an area of 44 centimeters squared. What is the actual length that a distance of 4.3 centimeter on the drawing represents? To start off this question, I'm going to make a summary of what information I've been provided with in the question. So the first one is an actual area equal to 712 meters squared. Now I'm going to want to convert that into centimeters squared. So I'm going to times it by 100 squared, and that's going to equal to 7,120,000 centimeters squared. I've also got a scaled area, which is equal to 44.5 centimeters squared. Then I've also got a scaled length equal to 5.3 centimeters. And the question is asking me what is the actual length of the corresponding side to the 5.3 centimeter side on this scaled drawing. So in order to answer that question, what I need to calculate is the scale factor. So I would normally, if I was calculating area using scale factor, I would use a formula similar to actual area. It's equal to the scaled area times by scale factor squared. So I can use that formula to work out what the scale factor is. First, I'm going to substitute in my known values. So actual area is 7,120,000, and that is going to equal to 44.5 times the scale factor squared. So I'm going to start rearranging my equation until I get the scale factor value by itself. So first I'm going to divide both sides by 44.5. So that leaves me with 160,000 is equal to the scale factor square. Now to calculate the scale factor, I need to square both sides. So the scale factor is equal to the square root of 160,000. So my scale factor is therefore equal to 400. So I've now worked out that my scale factor is equal to 400. I can proceed to calculate the actual length based on the scaled length of 5.3. So my actual length is going to equal my scaled length times by the scale factor, and that is going to equal to 5.3 times 400, which is equal to 2,120 centimeters, which I can convert into meters by dividing by 100. So my actual length is equal to 21.2 meters. So based on the information in the question, where we have an area of 712 meters squared, that is represented by a scale drawing with an area of 44.5 centimeters squared, we can figure out the scale factor of that enlargement is 400. So a scaled length of 5.3 centimeters is enlarged using that scale factor of 400 to an actual length of 2,120 centimeters or 21.2 meters.